Dear students, now we're here again in the second voice lecture for the Descriptive Statistics course. We already covered in the previous video how the two types of charts that can be used for describing the data, and the group data, the group data. Now we will move to the third type, that's the cumulative frequency polygon. To use the cumulative frequency polygon, we should first use the table for the frequencies and make the column for the frequency, cumulative frequency, like this. In this example, we already have classes and the frequency for each class. To make the frequency, cumulative frequency in each class, we should add the frequency for in each class to the frequency before. In the first class, we haven't already a frequency before, so the 8.0, because we haven't here, this is the first class and we haven't a value before and no classes before, so the frequency that become in the frequency, cumulative frequency column the same, which is equal to 8. The second class, the frequency equal to 11. So we will add the total frequency in the first class to the frequency in the second class to be the value 18. Then the third class, the frequency equal to 23. So we will add the three values for the first three classes, which is 8 plus 11 plus 23, to get the value of the cumulative frequency in the third class, which is equal to 42, and so on up to the final class, which is from 3000 to 3400. If we add the frequencies in all the previous classes, we will get the cumulative frequency in the final class equal to 180. Take care that the value in the cumulative column in the last class should be equal to the total frequencies. This value makes us sure that we are calculated every class frequency right, and no wrong in the any and no any classes. There is no wrong number added to the classes intervals. So be sure that the final class cumulative frequency should equal to the total number of frequencies. Here, the cumulative, how can we calculate the cumulative frequency? And now we will use this cumulative frequency to draw what is known as cumulative frequency distribution. Is the chart that we use to represent the cumulative frequency for any classes. Here we have two axes. The horizontal axis, we put the classes that we have, and in the vertical axis, we put the frequencies. Be sure that the value for the frequencies is suitable number for the value in the cumulative frequency columns that you have. And now we will begin to put the frequencies in each classes. Again, refer to the previous table for the frequency column. We find that in the first class from 200 up to 600, the value was in the cumulative frequency was 8. So if we note here, we will put this is up to 8. Take care that we refer to the upper limit for the first class. The upper limit for the first class is 600, so we will put the point dot and the dot here that represents the first class cumulative value in to the 600. Again, for the second class from 600 up to 1000, the cumulative frequency was 19. So the upper limit in the second class is 1000, and we will put the dot spots here in the second class up to 19. Here up to 19. Again, we use the upper limit in each class to put the dot in front of. And for the third class from 1000 up to 1400, we have the cumulative frequency equal to 42. So the upper limit is 100 in the third class is 1400, and the cumulative is equal to 42. So we will put here up to 42. Note that we are interested in the cumulative in each class and the numbers that value approximated by developing by cumulative frequency distribution and portraying it graphically in a cumulative frequency polygon to represent the relation between the cumulative of each class uh, in response of the frequencies. And also we can use the percentages in the same time by using another vertical axis to represent the percent of the values that we have. This is the way how to cumulative frequency distribution. Finally, again, we already represent in this subsection the three main graphs that are commonly used for representing a group data that we have already converted from the raw data and random data. The histograms here and the frequency polygons and the cumulative frequency distribution or cumulative frequency polygon. Another name for the cumulative frequency polygon is Pareto chart. Now, here we can easily represent the data. And another example, construct a histogram, frequency polygon, and OGIF. Again, OGIF means the cumulative frequency polygon. So, by using the relative frequencies for each distribution. Now, you should use relative frequencies. This means we will draw the same charts, but in the vertical axis, we represent what will represented by the relative frequencies, not the frequencies. We have the class boundaries here from beginning from the first class from 5.5 up to 10.5 and 10.5 up to 15 and so on, and each class frequency represented for each class. So that the requirement is using their relative frequency. Take care, please take care from these points that we want represented by frequencies or relative frequencies. You ought to use a relative frequency, so you should get the relative frequency for each class. This is by dividing the frequency in each class to the total values or the total frequencies. This is the relative frequency for the first class, which is equal 1/20 equal 0.05. 2 over 20 equal to 0.1. 3 over 20 equal to 0.15, and so on. This is the relative frequency column and will be represented in the y-axis or the vertical axis in these three charts. To draw the histogram, we will put the classes in the horizontal axis and the relative frequency in the vertical axis, like this. Here, the frequencies from the total frequency should be equal to 1, and we will begin by 0, 0.05, 0.1, and up to the final greater value here is 0.25. Now we represent the classes by using the relative frequencies. The first class from 5.5 up to 10.5, here the frequency is equal to 0.05. So we will draw a bar for this value up to 0.05, and then draw adjacent bar for the second class and no gaps in between. This is a histogram for the second class, which is equal to 0.1. So this part 0.1, and the third class, which is from 15.5 up to 20.5, the values will be adjacent and the part will be adjacent up to 0.15 here, and so on up to the final class, which is from 35.5 up to 45.5 equal to 0.1. So the histogram will be here by this. Now we will move to the second requirement for drawing the frequency polygon. Repeat it again that frequency polygon depends on the midpoints, so we should calculate the midpoint for each class and put the values for the midpoint on the horizontal axis like this. So the first class midpoint, this is values from 5.5 and 10.5, and we can calculate it direct. So we will use easily the rule for the midpoint, which is the upper limit plus the lower limit divided by 2, so equal to 8 for the first class, and the second class 10 plus 10.5 plus 15.5 divided by 2 equal to 30, and so on to the final class. And we'll put the values for the relative frequency on the vertical axis and the midpoints in the horizontal axis, and we will plot the values here in front of each midpoint. But don't forget to put the zero frequencies that we will add the class and class width to the final class and subtract the class width or class interval from the first class. Okay, this is by using zero values to be line here from the first dot or first value to the horizontal axis, and draw line here from the final value to and last value to the horizontal axis. This is the first and the last values get by subtracting the class interval or class width from the first midpoint and adding to the final midpoint. This is which we have already draw the frequency polygon. The final requirement or the third requirement is OGAV. OGAV again is the same for the cumulative frequency polygon. We use the cumulative frequency column here to get the to draw the cumulative frequency polygon. Again, we will use the cumulative relative frequency. Note this is very important here. Very important that the relative frequency here differs from the relative frequency in the first two graphs. The relative frequency in the cumulative frequency polygon, we make another column for the relative frequency cumulative. We first get the cumulative frequency for the classes and dividing all by the total value 20, and we will total frequencies and get the values in each cumulative class. So we will to draw algebra by using relative frequencies. We should use these two columns. The first gets the cumulative frequency and then gets the cumulative frequency. Here the cumulative frequencies by we get it by using the frequencies added to each previous one. Here here the first class equals to 1, the second class 1 plus 2, and the third class 3 plus 2 plus 1 equal to 3, and the fourth class 5 plus 3 plus 2 plus 1 equal to 6, and so on up to 20. But the requirement is we use the relative frequency. So you should get the relative frequency, cumulative relative frequency, by dividing 1 over 20 equal to 0.01, 3 over 20, 0.15, 6 over 20 equal 0.3, and so on. Take care from this, please. So we will go again to the algebra or the cumulative frequency polygon and putting the classes on the horizontal axis and the cumulative relative frequency. Take care, please. Cumulative here, cumulative relative frequency. Put it on the horizontal axis. Here, cumulative. This is by using this column, okay, from 0 up to 1. For the first class from 5.5 up to 10.5, we have the value equal to 0.05. Again, we use the upper boundary to determine where we will put the value. Okay, at the second, we are the upper value here 15.5, and the value in the cumulative relative frequency column equal 0.15. So we here the equal to 0.15, and so on up to the final should be equal in the final class should be equal to 1. Here is the example relating the relative frequencies by the three charts: histogram, frequency polygon, and algebra or cumulative frequency polygon. Here the charts again. Now let's move to the examples and exercises how to answer the questions if we have already the graph, but we ask about the data on the graph. The first example here, Molly Candle Shop have several retail stores in a coastal area of North and South California. Many of Molly's customers ask her to ship her purchases. The following charts show the number of packages shipped per day for the last 100 days. First requirement, what is this chart called? Of course, we are all know this is a chart is a histogram. Okay. The second requirement, what is the total number of frequencies? How to calculate the total number of frequencies, and we don't have the table for the classes and the frequencies. Easily, we can add the values that are here for the above in each part of the histogram chart: 5 plus 13 plus 28 plus 23 plus 18 plus 10 plus 3 to get the total frequencies that equal to 100. What is the class interval? We know that the class interval in the histogram is here added in the x-axis or in the horizontal axis. So we have the first class from 0 up to 5, the second is 5 up to 10, third the 10 up to 15. So easily we can find the class interval by subtracting the upper limit from the lower limit to get 10 minus 5 equal to 5, 15 minus 10 equal to 5, 10, 20 minus 15 equal to 5. So the class interval is or the class width equal to 5. What is the class frequency for the class from 10 up to 15? From 10 up to 15, we here find the class frequency equal to 28. What is the relative frequency for this class? We know that the relative frequency we can get by dividing the frequency in this class by the total frequencies, and we already answered the total frequencies equal to 100, so the relative frequency in this class will be 28 over 100, which is equal to 0.28. What is the midpoint of the class from 10 up to 15? To calculate the midpoint, we add the lower limit plus upper limit and divide it by 2, which is equal to 12.5. On how many days were there 25 or more packages shipped? Oh, take care from the kind of these questions. Here in these questions, we should use the chart on the horizontal axis and vertical axis in the answer. I know that we have here on the horizontal axis the frequencies, the classes, and the vertical axis the frequencies. What he asked about? He asked about 25 or more packages. So the number, which is the classes that he gave us the information, and the answer will be for the from the frequency of the vertical. If we have the information on the horizontal axis, the answer of us will we get by in the vertical axis. I mean, there were 25 or more. So the 25 or more, which is the two classes, the final classes and the previous final classes. So we add the two frequencies for this, which is 10 plus 3 equal to 30. This kind of questions is very important because it enables us to get information from the group data and from the graphs that we constructed upon the group data. Another example, the following chart shows the number of patients admitted daily to the hospital through the emergency room. We have number of patients on the this horizontal axis and the frequencies on the vertical axis. What is the midpoint of the 2 up to 4 classes? We have the classes here. You don't have the midpoints. So the midpoints in between here 0 and 2 is 0 plus 2 divided by 2, which is 2 divided by 2 is equal to 1. So the midpoint here equal to 1. And the midpoint here 2 plus 4 divided by 2, which is equal to 3. For the classes from 4 up to 6 is the midpoint equal to 5. Here, the classes from 6 up to 8, the midpoint equal to 7. And for the class from 8 up to 10, the midpoint equal to 9. And finally, the midpoint for the final class is equal to 11. So the midpoint for the class from 2 up to 4 is equal to 3. How many days where 2 up to patients are admitted? Now, remember again, we have the requirement or the question information on the horizontal axis. So we will get the answer from the vertical axis. Now, let's take the number P. that we have here. Okay, about days from 2 up to 4. From 2 up to 4, we have here this point. So if we take a horizontal line and get the information from the vertical axis, we find it's about 26. About means it's not actually the number because the chart is not accurate totally. So we have about 26. Number C, approximately how many days were studied. How many days that we also ask about the frequency. This question means how many frequencies or the total frequencies, how we calculate the total frequencies from the chart. This is by adding the frequencies at each dot. Okay, so we add here this value, maybe 15 or 16 plus 26 plus here maybe 20, here maybe 10 plus 8 plus 5 plus 0 plus 2 to get the all sum equal to about 76. Here the answer may vary. Take care, the answer may vary. But of course, you can approximate it into numbers that are closed. It's about 76, it's maybe 78, maybe 71, but it's never two answer. One is 50 and other equal 110, for example. It's approximation that is in a range that is acceptable, not over limit or lower limit this value. So we can approximate as possible accurate number. Okay, add all the frequencies and get the value that about the how many days we were studied. Number D, what is the class interval? The class interval here is subtracting the upper limit from the lower limit in any classes. We get 4 minus 2 equal to 2, so the class interval is equal to 2. What is the class chart? This chart called, of course, it's a frequency polygon. Another example for this type of exercises that we have already the chart and we asking about data that upon this chart. The following chart shows the selling price of houses selling price per $1,000 of houses sold in the Montana area. How many homes were studied? How can we know the number of homes were studied? This is by the frequencies in total frequencies. Let's remember that in the cumulative frequency polygon, the total value in the last class should equal to the total number of frequencies. So the total number of frequencies here in front of the last point on the cumulative chart. Number P, what is the class interval? We can calculate the class interval by subtracting any two classes if upper limit minus lower limit. Okay, so it's 50 up to 100 and take care that the selling price by $1,000. So this is the 100 minus 50 equal to 50 and the selling price by $1,000, so it's about 50,000. 100 number C, 100 homes sold for less than what amount? Take care in this type of questions because you should know what is the question asked about. He asks about the number of homes sold for less than what amount. So we have the information from the vertical axis and we want the selling price that the answer will be from the horizontal axis. Again, Now 100 homes, that is represent the frequency of homes sold for what amount. So we have 100 homes and take a line, straight line, and up to the curve, and then find the answer. Here we have arrow, and here we get the answer from the horizontal axis like this by using a ruler for of course, and we find it's about 180,000 because the number are by selling price by $1,000 to 180,000. Ticker, it's a pout. Now, again, we have a pout because it's not accurate in drawing, and it's in a range. So be sure that your answer may vary in the another answers, but it should be close to the right answer. So it's maybe 180, another one, say 182,000 and 185, maybe 175, but it's close to the right answer, not far away from the right answer. Number C, number D, about 75% of homes sold for less than what amount? Again, we have the value or the information for that on the vertical axis. The information about the 75% for houses. This is we know this value on the vertical axis. So we will use the vertical axis and go to 75% horizontal line up to our curve or the cumulative curve and get the value from the here, and this is the direction, and get the value here on the horizontal axis. It's about 240,000. Again, it's about because it's accurate, but it's you should get it close the true value. Estimate the number of homes in 150,000 up to 200,000 dollars. So we have the information on the x-axis or the horizontal axis, and we want the answer from the frequency for the right. So we will use what is the class interval from 150 up to 100. Here, this is the class interval. And what is the number of homes in this? It's about. So we have the value here beginning from the values and take the row. It's about 60 homes. So take care about the questions and the answer. How can we find it? The question that we start with the axis that we want to put. If the question have the information on the horizontal axis, so we start with the horizontal axis and get the answer from the vertical axis. But if the question like in the C and D requirement, if the question on the vertical gives the information on the vertical axis, we start with the vertical axis and get the answer on the horizontal axis. Another question about how many homes sold for less than 225,000. So the information on the vertical the information on the horizontal axis, which is 200 to $225,000, and we will get the answer from the vertical axis, which is how many homes. Now, here, this value is in this class. So we will take it approximately here 225, maybe in this point, and go, sorry for the line, but you can do it by the ruler more accurate, and here 225, here maybe 225, and get the horizontal line after the slope in the curve, cumulative curve, and it's about 120 ohms. Take care, it's all the values about because the answer may vary, but don't be far from the right answer. Now we covered the three main important charts that we are used for the group data. It's the most commonly used charts, and we already know how to draw the charts, and we also know if the charts are already drawn, how to get information from the charts. Another important chart is that you should know in the statistics that represent data, two types, that bar charts and time series charts. Bar graphs, we already use a bar graph for one case, but if we have a comparison for more than one case, we have what's known by a compound bar graph. A compound bar graph, for example, consider the following data: the number of a number in millions of never married adults in United States. We have two types, male and females, and we have 4 years. So in the horizontal axis, we put the years and the number or frequencies on the y-axis and the vertical axis. Of course, we put the number suitable for the values that we have, that the greater value is maybe 40.2. So we make the frequencies 5, 10, 15, and up to 45. And then drawing the two types, male and female, by adjacent pairs in each year to easily compare the values for. By looking a quick view for the graph, we can compare in each year the number of married adults and never married adults in males and female. So bar chart, this type can compare data for two or more groups. If we have another value groups, we can add a third bar in the same year, and this is used to quick view for group data and compare data. Another another type of chart is that used for the frequency distribution representation is the Pareto chart. The Pareto chart is used when we represent the frequency distribution for categorical variables. Uh, Whatever this is nominal or ordinal data, but the main step in the Pareto chart is arranging the frequencies from the highest of vertical in order from highest to lowest. So in the example, the data shown here consists of the number of police calls for specific categories from that is local received in 2011. Draw and analyze the data by using a Pareto chart for the data. Now this data here in this table, the first step, we should arrange the data from the highest value to the lowest value. Just we arrange. So this is the data after arrangement, and we draw at the x-axis and put the values and which is the category variables, and on the vertical axis we put the number of the number or the frequencies. 0 up to 100 because the highest value is 92, so we put these values. according to the values in the here in the table. So in the horizontal axis, we represent the 5 categories that we have and represent each frequency by bars that are adjacent to each other. So here in the first bar, the total value is 92, and the second bar is 79, and the third bar is 65 and 38, and finally in the fifth bar is 27. This gives us quick review of what is the highest frequency and highest number, and what is the the lowest number this Pareto chart uses. And the final graph we have here is the time series graph. A time series graph represents the data that occur over a specific period of time. The time series graph is related to the time that we want to represent data over sequences over the time or years. So the data are represented in years, and the percent in each year are here in the table. We want to draw a time series graph for the data. So we find x-axis and label the years that we have on the x-axis, and on the y-axis we put the percentages that we have, and plotting each point according to the table or the information given. So 1970 we plot it here, and so on up to 2010. And then we use a ruler to get the chart like this. Here we can compare more than 2 time series. If 2 or more data sets can be compared by using compound time series graph. So here again we have what's named by compound time series graph. If we have more than two time series, we can draw each simultaneously in the same graph and compare it and get all the information from the graph. Now it's time for you. You have the following exercise. Do your best for answering this exercise. It's a very important exercise related that what we are taking in this chapter. We already finished this chapter, and in the next video we will take a new chapter and methods for calculating data and the measures in the statistical techniques. Study hard to finish this part and answer these questions, and you have these questions again. All questions that we have like this in and answered examples. You can do it, trust yourself, and I'll with you in any question related to these topics. Thank you for all.